Assalamu alaikum, guys and doctor. Today I will explain what we did in our question. I will read the introduction of our question. Please, I will share screen. The introduction. First, contaminated air containing 3% acetone and 2% of water is fed to an absorber column as shown in the figure below. The mass flow rate of air is 100 kilogram by hour. Pure water is used as an absorbent to absorb acetone from air. The air leaving the absorber should be free of acetone and contains 0.5% water. The bottom liquid of the absorber is fed to distillation column to separate acetone from water. The bottom stream of the distillation column was found to contain 4% acetone, and the balance is water. The vapor from the overhead of the distillation column was totally condensed and split into two portions. One portion is recycled to the column and the second fraction forms to the distillate product stream. And the concentration of the condensate is found to be 99% of acetone. And the small information, all percentage are in white. Now, after I finished our introduction, I will read our questions and I will try to explain it. The first question is A. Calculate the number of degree of freedom at the absorber, distillation, and the overall processes. For this question, its solution needs to draw a flow chart and draw the inputs, which are masses and weight of water, air, and outputs. And then we will calculate the air balance and the acetone balance in preparation for calculating the degree of freedom at both distillation, absorption, and distillation, and the overall process for the question A. But for the question B, it's saying calculate the flow rate kilogram by hour of M2 and M and M3 and M4 and M5. To solve the second question, we also need to draw the flow chart and write the blocks shown in the introduction above, such as M4, M6, and M7. And through them, we can calculate the mass balance overall and calculate the values of all values in the required in the above question. This for question A and question B. For DOF, the DOF, we can say the degree of freedom for overall system is 4, M2, M3, M5, M7. -3 acetone, water, air. This equal cancel this DOF. This is our introduction. That was my part. I will leave the second and third part to my friends to show it to you.
Luckily, it is a direct question actually because the question already gives the overall flow rate. So if you want to find all the unknowns, we need to divide into two subsystems, which is absorber and distillation as the question stated. For the condenser, no need to find it because the question doesn't want to know the mass balance for condenser and M6 and also R. So we can find the mass flow rate for M2, M3, and M4 based on this flow chart of subsystem boundary 1 absorber. Basically, we already know the number of unknown and material balance. We get 3 number of unknown, which is M2, M3, and M4, and 3 material balance, which is air, acetone, and water. So we can find the degree of freedom that equal number of unknown minus material balance. degree of freedom is equal to 3 minus 3 equal to 0. It means that it can be solved because we have the necessary equations that related to the unknown. Since we know that the degree of freedom is equal to 0, that means we can find all the unknowns in this flowchart for subsystem boundary 1 of a solver. First equation is for overall balance. Overall balance is like input equal to output. So for overall balance, the equation is M1 plus M2 equal to M3 plus M4. Then just replace the value that we know from this flowchart to the first equation. Now we get 100 plus M2 equal to M3 plus M4. We cannot solve M2, M3, and M4 since it have 3 unknown. Then we need to find others equation. Next equation is composition equation for air balance. We can find the M3. So the equation is equal to 100 times 0.95 equal to M3 times 0.95. And next, we also can find the M4 based on the third equation, which is acetone balance. The equation is 100 times 0.03 equal to M4 times 0.19. Both air balance and acetone balance has only one unknown, which are M3 and M4 respectively. Now we can get the M3 is equal to 95.477 kg per hour and M4 is equal 15.789 kg per hour. After we know the value of M3 and M4, we can put the value into the first equation since we already know the M3 and M4. Now for the first equation, we only have one unknown, which is M2, and we can get M2 equal to 11.266 kg per hour. So we can find all the unknowns for absorber, which is subsystem boundary 1.
Can get the mass flow rate 5 and mass flow rate 7 from the subsystem boundary 2. Subsystem boundary 2 is a distillation column. From the flowchart of the subsystem boundary 2, we can get two unknowns, which is M7 and M5, and two material balance, which is acetone and water. So the degree of freedom for this flowchart is basically 0. We can solve the unknown variables. For the overall mass balance for subsystem boundary 2 is M4 equal to M7 plus M5. We already get M4 from the subsystem boundary 1, which is absorber column. The amount of M4 is 15.789 kg per hour. We put M7 equal to 15.789 minus M5 as the first equation. Next is acetone balance. We times M4, which is 15.789 times with 0.19 equal to M7 times with 0.99 plus M5 times 0.04. We rearrange it and put it as the second equation. To solve it, we substitute the first equation into the second equation. Then we can get M5 is equal to 13.297 kg per hour. When we get M5, we can solve M7, which is we minus 15.789 minus 13.297 equal to 2.462 kg per hour. So for the final answer for flow rate, M2 equal to 11.266 kg per hour, M3 equal to 95.477 kg per hour, M4 equal to 15.789 kg per hour, M5 is equal to 13.297 kg per hour, and M7 equal to 2.492 kg per hour. That's all from us. Thank you for watching.